Alright, good afternoon. Welcome to Algebra 1 Remote Edition here at ICA Academy. Up on my board right now, I have a problem of the day, but really quick. You guys just took your test on Friday on Chapter 5. They were really good. I'm really happy with the scores. I will give them back as soon as you guys come back to school. Your maintenance, you should have received your maintenance over the weekend. It was in an email to your parents. And the next couple of days, this is actually an okay week for you guys not to physically be here. Actually, it's not an okay week ever. But we're kind of doing a little stepping stone. We're going to pop into Chapter 7. We're skipping Chapter 6 and most of Chapter 7 because they're going to be hit really hard in Algebra 2 next year. And we're just going to do the sections on negative exponents and scientific notation really quick in Chapter 7. And then we're moving on to Chapter 8, 9, 10, and 11. And that's how we're going to finish up the year. Those are some really heavy concepts that need to be covered in Algebra 1. So it's not such a bad week for you guys only. So let's go ahead. We've been working with exponents. We've been working with polynomials, exponent rules, how to operate, how to combine, how to simplify. So I've got 3 problems up on the board. So go ahead and pause the video right now, rewrite them, pause, and simplify. Alright, hopefully you paused. And if you didn't, then you're just going to do it with me. Let's go ahead and write this in expanded notation so you can see, see where we're going today. So we have 9 x's. X times itself 9 times. 4, 5, 6, 7, 8, 9 over x times itself 3 times. So I have 1, 1, 1, and in my numerator I have x to the 6th. Fair enough. Let's do the same thing here. I have x times x over x times itself 9 times. 2, 3, 4, 5, 6, 7, 8, 9. All right? Single, single, single. So I have to account for my 1 up here, and I have 1 over x to the 6th. And what I have here is something divided by itself. So I have x times itself 3 times over x times itself 3 times, which equals 1. Now we're going to go ahead and talk about all 3 of these and what they're going to mean for negative exponents. And like we've said, and I continue to say in class, is an exponent tells you how many times to multiply a number or a term by itself, right? So you're thinking to yourself, where's she going with this whole negative thing? Can you multiply something by itself a negative amount of times? Can you do something a negative amount of times? Even if I walk backwards, am I still moving a positive distance? I am. So what's this whole negative exponent business? All right. What we're getting into, the long and the short of it, is if I have, let's take this b for example. I can rewrite this. 1 over x to the 6th is equivalent to x to the negative 6. I can't operate with something to the negative 6. This is the simplified, not even the simplified version of it. These two are just equivalent. In order to operate, you have to take the reciprocal, and as soon as you move your term with your exponent down into the denominator, it becomes positive. And let's talk about why. So let's go back to this example right here. What in effect I did is I had x to the 9th over x to the 3rd, x cubed, which is equal, I subtract my exponent on the bottom from my exponent on the top. It's the same as saying 9 minus 3. So x is the same, or x to the 9th 9 minus 3 power is the same as saying x to the 6th. If I go down here and do the same thing, I have the bottom number subtracted from the top exponent. So I have x to the 3 minus 9, which is x to the negative 6, which doesn't make a lot of sense. I can't multiply something by itself a negative 6 amount of times. But how you would operate with this is you would, let's just say it like it is. You flip it over, you put it in the bottom, in the denominator, and you put a 1 on top of it. Okay, it has to do with the place value of everything when we think back, way back to where exponents really come from. We're going to do some practice with this. This example down here, if I did what I did here and had x to the 3 minus 3 and simplified using one of my exponent rules, I have what is x to the 0. And this doesn't make a whole lot of conceptual sense to teenagers usually. That x to the 0 is, in fact, 1. And why does that happen? Well, for this reason in and of itself. If I have x to the 3rd over x to the 3rd, and I forget about this right here, something divided by itself is equal to 1. It's the rule we use all the time. 2 divided by 2 is 1. 100 divided by 100 is 1. Now, why it makes sense that x to the 0 power is equal to 1 is illustrated here, and we're going to do some more practice with it. But we have x over x, x over x, x over x. This is 1, this is 1, this is 1. 1 times 1 times 1 is not 0, don't say it. 1 times 1 times 1 is 1. Okay? So, anything to the 0 power is 1. Because let's think about this. If I have 3 to the 0 power, it's 1. Because 3 to the first power is 3 multiplied by itself, just like that one time. So 3 times nothing is equal to 3. 3 squared is equal to 3 times 3, which is 9. And we could go more and more and more and on and on and on. So these are just some examples that hopefully give you a conceptual idea of why. All right, let's go ahead and open up your book to page 331, please. All right, we've got the definition of a number to a negative exponent, a to the negative n. It gives us the definition right there, and it says a to the negative n is equal to 1 over a to the n power. And that's the definition. That's, by definition, mathematical definition, what that is. So we can go ahead and look down at the examples. Go ahead and look down the example at example 1. We've got 10 to the negative 3 is the same as 1 over 10 to the 3rd, which is 1 over 1 with 3 zeros after it. 1, 3 zeros. That's where those numbers came from. Let's go ahead and look at B. 5 to the negative 4th. Okay? Let's go ahead and take the reciprocal. We make our exponent positive. We flip it over, put a 1 on top. We have 1 over 5 to the 4th. We have C, 16 to the negative 1. And we have 1 over 16 to the first power, which is simply 1 over 16. All right, let's go ahead and do another quick example. It also actually reminds you down here on this page, you can go back to page 190. We've already done this at the beginning of, I want to say it was chapter 4, of these exponent rules. So let's really quick go ahead and look at example 1 right here. We've got 11 to the negative 2. All right, I'm going to take the reciprocal. I'm going to flip it over and have 1 over 11 squared, which is the same as 1 over 11 times 11, and 11 times 11 is 121. Are we okay there? It's as though I'm talking to you guys, and I expect you to nod your heads and say yes. It's very weird. All right, let's go ahead and look at example 2 here. This one's a little more difficult. We're going to use the rule that we just used on the problem of the day. We have 6 over 6 to the negative 2. We can say that this is like 6 to the 1. It's not 6 to the 0 power, it's 6 to the 1 power. So we have, in effect, let's write this as an equation. 6 to the 1 minus negative 2. 1 minus negative 2 power. Or, you could move this up to the numerator and add 6 to the 1 times 6 to the 2 all over 1. Okay, so you have, in effect here, 6 cubed, and this is the same as 6 cubed. So 6 times 6 is 36. 36 times 6 is 216. So we have 216 here. And we'll do more and more practice there. Let's go ahead and look at the next problem we have. I'm just looking at the time on the video. Oh, beautiful. If you turn to the next page, it actually gives you all the rules, nice and simplified, in a table. So let's just, I'm going to leave the examples for you to look at yourself because you can read the book, hopefully. I have faith in you. I'm going to do a couple of problems from my book that are not in your book to give you some more examples and then set you free, and this should be a pretty easy kind of day. Alright, so I think we're on example 3. Example 3, we have 4 to the negative third. Example 4, we have 5 to the 7th times 5 to the negative 9. We have, and you got to remember your exponent rules here, people. So go ahead and start writing them down and simplifying them, and then I will follow and do them with you. Use all those exponent rules that we've learned, not just the 2 I talked to you about today. All right. Go ahead and finish writing those down. I'm going to pause the video so I can, it takes a shorter period of time to upload a shorter video than a longer video. So at 15 minutes, which we're at like 14 minutes right here, I'm going to pause this and I'm going to come right back.